On the 15th day of October, concealed behind the solar disk, 3 entities materialized in proximity to 3i Atlas, entities that possessed no authorization to be present. The Sun, which had maintained an uncharacteristic state of dormancy for several weeks, suddenly reawakened with extreme intensity, unleashing not a single, nor a double, but a triple outburst as each of these mysterious objects traversed its celestial path. Every moment of this event was captured on film. The movement exhibited was remarkably precise, unnaturally so, and displayed a level of perfection that precluded any possibility of random occurrence. Despite this undeniable evidence, a profound silence ensued. There was no official pronouncement, no prominent headline. This response is characteristic of a deliberate suppression of information. Alternatively, it is possible they are operating under the assumption that their actions will go unnoticed. However, they are mistaken. Tonight we shall embark on a journey through redacted data, and the revelation we unearth at the conclusion will offer a glimpse into the most perilous secret currently held within the field of astronomy. If these enigmas continue to disrupt your sleep, as they do mine, ensure you signify your engagement by tapping the like button and subscribing to our channel, thus ensuring your presence for every unfolding revelation as it occurs in real time. Please share your location in the comments section, indicate the current time on your clock, and be candid. Do you believe we are being afforded the complete truth regarding these mysteries? Furthermore, if you wish to expand this discourse, disseminate this video across X, Facebook, Reddit, or even within your private group communications. This community thrives because of your involvement, and your sustained support empowers us to continue pursuing truths that the world would prefer to overlook. Part 1 delves into the unprecedented footage. Envision yourself observing a live broadcast on a typical Tuesday afternoon. The sun appears on your display, serene and distant, a golden orb suspended in the void of digital space. But then, a shift occurs. 3 dark, unidentified objects navigating with unerring accuracy glide sequentially across the frame. Each one arrives, and shortly after each departs, the sun erupts, not once, not twice, but on 3 distinct occasions. The sun had been notably subdued for weeks. However, the instant these objects entered its vicinity, it erupted violently, as if startled by an electrical surge. This is not conjecture. This is precisely what amateur astronomer Tiago, known online by the handle Dobsonian Power, documented and disseminated to the global populace this week, and it has fundamentally challenged our long-held assumptions regarding the permissible occurrences within our solar system. The imagery originates from LASCO, the large-angle and spectrometric coronagraph instruments situated aboard the Solar and Heliospheric Observatory, or SOHO, a satellite that has meticulously observed the sun without interruption for 3 decades. These are not indistinct smartphone captures or creatively interpreted visuals. This is official data, the very same imagery that NASA scientists scrutinize on a daily basis. What Tiago observed represented a phenomenon that, according to our present comprehension of celestial mechanics and solar physics, should not exist. The trio of objects he documented were perfectly aligned. They advanced in a coordinated formation. They were not haphazard fragments of cosmic detritus drifting towards our star. Their trajectories suggested deliberate intent. Their precise timing implied coordinated action. Upon publishing his findings, Tiago characterized them as companions or shadowy elements associated with 3 Atlas, the interstellar entity that arrived from beyond our solar system in the latter part of the year 2024. The online astronomical community was galvanized by this disclosure. It is at this juncture that the narrative begins to present an uncomfortable challenge to mainstream scientific consensus. The statistical likelihood of 3 independent entities simultaneously precipitating 3 solar events in succession is so infinitesimally small that attempting to explain it through conventional probability calculations would be met with derision. We're not discussing mere improbability. We're addressing a degree of unlikelihood that compels one to pause and contemplate whether a more profound underlying phenomenon is at play. 3 objects, 3 incandescent outbursts. The pattern is impeccably clean. The timing is astonishingly precise. The coincidence is impossibly perfect. When one operates within any discipline that necessitates data analysis, a crucial understanding is acquired. Patterns of this nature do not arise by chance. They are the consequence of an external driving force. Nevertheless, a subsequent silence descended. There was no press conference from NASA, no official statement from the ESA, and no acknowledgement from any prominent space agency or research institution. The very bodies tasked with deciphering our solar system offered no response. In an era where every scientific breakthrough is widely publicized and celebrated, where the detection of distant exoplanets and gravitational waves garners immediate global attention, the images of these 3 objects, after passing through official channels, encountered what can only be described as institutional radio silence. This dearth of commentary effectively constitutes its own declaration, thereby generating its own set of profound questions. Why would the organizations responsible for monitoring all solar activity, employing thousands of scientific minds, maintain absolute quietude regarding an event that fundamentally challenges our established understanding of what is feasible in the immediate solar environment? Independent observers were also bearing witness. Skywatchers onks, identified as Night Monkey and Tobazil, both seasoned in the identification of celestial occurrences, reported observing swift-moving points of light in the vicinity of Gemini and across various sky surveys. Their observations corroborated Tiago's timeline. Multiple independent sources, utilizing disparate equipment and from diverse vantage points, all reported the identical phenomenon within the same temporal window. When a solitary observer reports an unusual event, it is categorized as a curiosity. When 5 observers independently report the same occurrence, it constitutes corroboration. When institutions disregard such corroboration, one is compelled to question the underlying motivations. The reasons for this silence are readily discernible. The discovery of artificial objects in the immediate solar vicinity would necessitate a complete re-evaluation of humanity's place in the cosmos. It would instantaneously transform from a scientific curiosity into a global geopolitical crisis. It would precipitate complex legal, military, and existential quandaries for which no government or scientific body is adequately prepared. There is a perceived safety in maintaining silence. There is a sense of protection in feigning ignorance. However, silence invariably creates a void, and a void invariably invites speculation, the propagation of conspiracy theories, and the inevitable deluge of misinformation. A more judicious and forthright approach would involve the open acknowledgement and thorough investigation of what was observed. Instead, we are left with a question that the official scientific establishment resolutely refuses to pose. Could this represent the inaugural publicly documented instance of kinetic intervention within solar physics? Are we, in real time, witnessing humanity's inaugural encounter with non-human intelligence? These are the very questions that keep us awake at night, and they are initiated by 3 objects and 3 outbursts that those in positions of power are unwilling to discuss. Part 2 examines pattern recognition versus a deliberate cover-up. Probability serves as a stark and revealing indicator. When one applies it to the events surrounding 3i Atlas, a striking truth becomes immediately apparent. If 3 distinct entities, each entering the solar vicinity, each independently triggering solar flares, were to occur purely by chance, purely coincidentally, the statistical odds would be comparable to shuffling a deck of cards and drawing the ace of spades 500 consecutive times. While not technically impossible, it is so extraordinarily improbable that proposing such an event as a product of chance amounts to a declaration of either profound ignorance or deliberate evasion. The human brain is inherently predisposed to identifying patterns. This evolutionary trait was instrumental in our species' survival. A recurring pattern, be it indicative of a predator or prey, commands our attention. A repeating rhythm invites our investigation. 3 consecutive solar eruptions following 3 distinct object passages do not constitute mere background noise, they represent a definitive signal. Yet it is at this juncture that institutional science retreats, adopting a defensive posture. Scientists consistently assert that correlation does not equate to causation. They emphasize that extraordinary claims necessitate extraordinary evidence, and that maintaining a healthy degree of skepticism is paramount. All of these tenets are valid and critically important. However, healthy skepticism can devolve into a detrimental pathology when it actively seeks to disregard evidence that challenges established models. When we reject data solely because it conflicts with our pre-existing knowledge, we're not acting scientifically, we're exhibiting dogmatism. We're prioritizing the preservation of our theories over the pursuit of truth. Sabine Hosenfelder, a physicist with decades of established credibility, has specifically cautioned against this very tendency. She has publicly stated that the outright rejection of the possibility of an artificial origin without rigorous investigation would constitute the most significant error our civilization could possibly commit. Not just any error, but the paramount mistake that truly matters. The chronological sequence of these events is of utmost importance here. Therefore, let us meticulously retrace them. In the weeks preceding Tiago's observations, the sun had been remarkably quiescent. Solar activity was significantly diminished, as if the star itself were in a state of repose. Subsequently, 3 Atlas approached, accompanied by these 3 attendant entities. The very moment they passed in close proximity to the solar surface, the star experienced a dramatic awakening. The eruptions occurred in rapid succession, resembling a cascade of responses, as if the sun were reacting to an external stimulus, defending itself against an unseen threat, or perhaps being deliberately activated by some unknown force. Historical precedents offer valuable insights. When military authorities first encountered the phenomenon of unidentified aerial phenomena in the mid-20th century, their initial response was not immediate declassification. Instead, they imposed secrecy, compartmentalized information, and maintained institutional silence while conducting private investigations. It is now widely understood that government agencies and military branches continuously tracked anomalous objects and events, yet divulged virtually nothing to the public. This period of secrecy persisted for 70 years. Why would the current situation be any different? Independent confirmations have continued to surface. Night Monkey documented rapidly moving signatures across multiple comprehensive sky surveys, while Tabazil tracked objects exhibiting motion inconsistent with standard cometary behavior or predictable orbital debris patterns. Other amateur astronomers, utilizing publicly accessible data from SOHO and other solar observation platforms, have identified additional anomalies that the mainstream astronomical community has conspicuously failed to address. This is not a solitary observer presenting unsubstantiated claims. It is an accumulating body of independent documentation, pointing towards a tangible, measurable phenomenon that exists within our data, yet has not been integrated into our official narrative concerning events in near-solar space. The more closely we scrutinize the available facts, the more untenable institutional silence becomes. However, the opposing viewpoint warrants consideration. Space agencies frequently defer public statements until definitive verification is obtained. They face legitimate pressure to ensure that observed anomalies are indeed genuine before broadcasting them to the world. The risk of premature announcement, of proclaiming a discovery that subsequently proves to be an instrumental artifact or a misinterpretation of data, is a tangible and serious concern. Scientific credibility is painstakingly earned and can be swiftly eroded. Rushing to definitive conclusions, even when confronted with compelling patterns, can undermine the authority of institutions upon which we rely for critical information about our planet and our solar system. This represents the fundamental tension at the heart of this matter. On one side stands institutional caution and adherence to the scientific method. On the other side lie the principles of transparency and public access to information concerning events that could possess profound implications. Both of these values are significant and generate legitimate expectations. Neither can be fully realized without some compromise of the other. However, there is one course of action we absolutely cannot adopt, yet seem to be pursuing nonetheless. We cannot simply pretend these anomalies do not exist. We cannot dismiss independent observations simply because they cause us discomfort. We cannot maintain silence as evidence continues to mount, because prolonged silence inevitably morphs into complicity. It becomes a conscious choice. It evolves into institutional corruption masquerading as prudence. The discernible pattern is evident. 3 objects, 3 solar outbursts, 3 independent observers documenting the identical phenomenon within the same temporal framework. The evidence is unambiguous. It is not subtle. It is not obscured by noise or distortion. It is plainly visible within our own data, awaiting acknowledgement from those in authority simply to confirm its existence. And as we transition from this examination of timing and correlation to the intrinsic nature of the light itself, the mystery deepens into something far more peculiar. We must now investigate polarization and what it can reveal about the composition and origin of 3 Atlas itself. Part 3 presents the polarization paradox. Light propagates as a wave, and like all waves, it oscillates. Under normal conditions, this oscillation occurs in all directions perpendicular to the direction of travel, akin to a pebble dropped into still water, creating ripples that spread outward uniformly. However, when light interacts with dust particles, ice crystals, or complex surfaces, a remarkable phenomenon occurs. The wave's oscillation becomes organized, preferentially oscillating in one particular direction, or a few. This phenomenon is termed polarization. Polarization is exceptionally sensitive to the physical characteristics of whatever the light has reflected off or passed through. For decades, scientists have employed polarization analysis to study comets. They possess a comprehensive understanding of the polarization patterns expected from various types of dust particles. They're aware of how ice grains polarize light differently from silicate minerals. They have established a catalogue of typical responses, a baseline depicting the behaviour of ordinary comets as sunlight permeates their dusty envelopes and reflects back towards Earth. 3 Atlas deviates from this baseline so profoundly that the researchers who conducted its analysis were compelled to publish their findings under titles that conveyed extreme uncertainty and apprehension. A paper authored by Gray and his colleagues documents extremely negative polarization in 3 Atlas, reaching values of -2.7% on curves where most comets exhibit values between 0 and 2%. This is not a minor discrepancy. This falls outside the realm of normal variation. This represents a pattern so aberrant that existing models of dust and ice behavior struggle to provide a satisfactory explanation. The angle of polarization inversion is incorrect. The phase curve does not align with expected parameters. The entire optical signature suggests the presence of something that should not be there. If 3 Atlas is indeed a typical comet composed of ordinary ice and dust, imagine attempting to identify a human by their fingerprint, only to find that the fingerprint does not match any existing database or any known human pattern. The ridges flow in incorrect directions. The patterns defy established human anatomy. One would immediately suspect either that the fingerprint is fraudulent, deliberately fabricated, or that one is dealing with an individual whose biological makeup fundamentally differs from the human norm. This is precisely what the polarization data is indicating. Either 3 Atlas possesses a surface composed of materials not commonly observed within our solar system, or its structure and texture are unlike anything catalogued to date. This naturally leads to speculation. If not ordinary dust, then what? Perhaps exotic ices, synthesized materials, or surfaces engineered to exhibit specific reflective properties. The prevailing scientific response has been to propose what researchers term a dust-rich gas-poor comet model. This hypothesis suggests that 3E Atlas consists almost exclusively of solid matter, with a minimal gaseous component, and that the dust particles themselves are larger and denser than those typically found in comets. This would serve to suppress the characteristic spectral signatures we normally associate with comets, while potentially accounting for some of the observed polarization anomalies through the sheer size and density of the particles rather than their chemical composition. This is a reasonable hypothesis. It is scientifically coherent. Critically, it is also a hypothesis that conveniently refrains from challenging our existing cosmological frameworks. It firmly categorizes 3E Atlas as an unusual, yet ultimately natural phenomenon. Avi Loeb, the astrophysicist who has demonstrated the greatest willingness to consider artificial origins, assigns this natural explanation a probability of approximately 4 out of 10. This implies that he attributes a probability of 6 out of 10 or higher to an alternative, more exotic, and potentially more deliberate explanation. When confronted with such figures, one ought to pause. A scientist of Loeb's standing suggesting that non-natural origins are more probable than natural ones does not equate to a declaration of belief in extraterrestrial life. It is not an assertion of certainty. Rather, it is a statement that the observed anomalies are so severe, so contrary to expectations, that the conventional explanation is, in fact, the minority position among experts who are prepared to engage with the data honestly. This pattern of discrepancy recurs across every analytical layer. The data points towards an unconventional conclusion, while existing models struggle to accommodate it. Institutions maintain their silence, and all the while, light bends in ways we do not fully comprehend, revealing a surface or structure that defies our established categories. What polarization analysis reveals is a physical characteristic of 3I Atlas that directly contradicts our fundamental assumptions. However, the truly damning evidence, the information that causes genuine discomfort among scientists, lies not in how light refracts around this object, but in the constituent elements that comprise it. We must now examine its spectrum, the chemical signatures that 3 Atlas is broadcasting into the vastness of space. Part 4 explores the chemistry of this outlier. Spectroscopy can be understood as a form of cosmic forensic investigation. When light interacts with matter, whether by passing through it or reflecting off it, each chemical element leaves behind a distinct signature, akin to a fingerprint imprinted upon the spectrum. For instance, nickel produces a specific spectral line, iron creates another, and cyanide generates yet another. Scientists have meticulously catalogued these signatures for every known element. Consequently, by analysing a spectrum, they can precisely identify celestial constituents, quantify their abundance, and ascertain their distribution. When the Keck Observatory, one of the world's most powerful terrestrial telescopes, focused its instruments on 3I Atlas and captured its spectral data, an unprecedented finding emerged. Nickel emission lines were detected. This in itself is not inherently surprising, as nickel is present in comets. However, this is where the situation becomes profoundly intriguing. The spectral lines corresponding to iron were conspicuously absent, or more accurately, they were suppressed to an unusually low degree. The ratio of nickel to iron in 3 Atlas is orders of magnitude greater than observed in any known comet. This anomaly is not merely unusual, it directly contradicts our comprehensive understanding of how celestial bodies within our solar system are formed. The implications become even sharper when we consider the cyanide ratios. Cyanide emission is a standard characteristic of comets, consistently appearing across diverse celestial objects. Yet, in 3 Atlas, the nickel to cyanide ratio is astronomically high. It is so extreme that attempting to propose it as a naturally occurring phenomenon without further elaborate explanation would result in professional ridicule from peer review. Nevertheless, this data undeniably exists. The Keck Observatory meticulously recorded it. Researchers have published these findings, and the mainstream astronomical community has largely either disregarded them or attempted to rationalize them using the dust-rich comet model. However, it is at this point that industrial chemistry enters the discourse, and the implications become genuinely unsettling. Nickel carbonyl is a compound with precisely one significant terrestrial application. It is utilized in industrial processes, specifically within metallurgical cycles, for the extraction and purification of nickel on an industrial scale. This compound forms when nickel is exposed to carbon monoxide under specific environmental conditions. It is not commonly encountered in natural settings. It is a manufactured substance. Consequently, when one observes elevated concentrations of nickel divorced from its typical iron counterparts, when one notes ratios that defy natural formation processes, and when one encounters combinations that strongly suggest industrial metallurgy, it becomes imperative to pose the question, could something be deliberately separating these elements? The immediate and logical counterargument posits that natural pathways for nickel carbonyl formation do exist within the interstellar medium. Carbon monoxide is present, as is nickel, and under the appropriate conditions of temperature and pressure, these compounds can naturally arise. This process does not necessitate technology or intelligence, it simply requires chemistry and time. Avi Loeb himself acknowledges this, assigning a probability of 4 out of 10 to the possibility of artificial origin, indicating that natural pathways remain plausible explanations. This point is critical. This is where our analysis must be rigorously precise. We cannot observe a chemical anomaly and immediately leap to conclusions about extraterrestrial life. That is not the methodology of science. That's precisely how confirmation bias operates. We have a responsibility to entertain multiple hypotheses concurrently in our minds. While natural geological processes might account for the observed nickel concentrations, the possibility of deliberate material segregation and refinement cannot be disregarded. Both explanations remain plausible. Both are substantiated by the available data. The core issue isn't about declaring one hypothesis correct and the other false. The crucial question is to determine which scenario holds greater probability and what additional evidence would be necessary to definitively favour one perspective over the other. This is precisely where the prevailing institutional silence becomes particularly vexing, as the logical next phase of inquiry is self-evident. We require more detailed spectroscopic readings. We need enhanced resolution. Our understanding must extend beyond merely identifying the constituent elements. We must ascertain their precise distribution within 3i Atlas and the specific physical arrangements they occupy. We must scrutinize the isotopic ratios, as these can reveal whether these elements originated from the interstellar medium or from processed stellar environments. A comparative analysis with every other interstellar object we have ever catalogued is essential to ascertain if these ratios are observed elsewhere, or if 3i Atlas represents a unique case. These are all rational lines of investigation that any well-funded research initiative should be actively pursuing at this very moment. Yet, scant resources are being allocated to these endeavours. Very few scholarly articles are being published. Minimal discourse is occurring at significant astronomical symposiums. It's as if the scientific community has collectively concluded that this particular inquiry is unworthy of exploration. And when the scientific community arrives at such a unified stance, one is compelled to question what they are endeavouring to safeguard. The chemical signatures strongly suggest an artificial origin, or at the very least something fundamentally anomalous. However, chemistry alone does not definitively resolve the matter. We must examine the physical architecture of 3i Atlas itself, scrutinizing the raw imagery captured of its central core, because the visual evidence observed there unlocks an entirely new domain of potential explanations and conjectures. Part 5. The Stingray and the Pyramid. Raw imagery obtained from the Gemini Observatory narrates a story that transcends spectroscopy and polarization, venturing into territory that causes pronounced discomfort among skeptics. The nucleus of 3i Atlas, when subjected to examination through the highest available resolution images, does not conform to the irregularly shaped, potato-like form typical of most comets. Instead, observers have consistently reported perceiving what they describe as a configuration resembling a stingray, exhibiting indications of structure and geometric regularity that diverge from random formations. Certain viewers, delving deeply into speculative interpretations, have identified what they perceive as stepped pyramid or ziggurat-like structures. Now, before we proceed further, let us establish absolute clarity regarding our observations. Images acquired by telescopes are inherently subject to pixelation. They can be distorted by atmospheric turbulence. They may contain artifacts introduced during the imaging process itself. The human brain is an extraordinary pattern recognition engine, honed over hundreds of thousands of years of evolutionary development to perceive intention and design even in their absence. We discern faces in clouds, perceive conspiracies within statistical fluctuations, and imbue randomness with meaning. This is not inherently a deficiency. Rather, it is a fundamental aspect of our survival mechanisms. However, it also serves as a significant source of error when applied to astronomical data. And yet, despite these caveats, the question of morphology remains critically important. An asteroid exhibiting a perfectly spherical shape would signify an unusual occurrence. An asteroid meticulously shaped like a perfect cube would indicate something even more extraordinary. Form inherently conveys information. Shape can elucidate formation processes. Shape can reveal intentional design, should such design exist. The debate surrounding the shape of 3i Atlas is not an abstract discussion. It is a tangible one. Multiple observers, utilizing disparate telescopes at varying temporal junctures, have reported recurring geometric features within the imagery. These are not isolated pronouncements from fringe individuals or conspiracy adherents. Rather, these are independent observations from conscientious amateur and professional astronomers who are willing to place their professional reputations on the line based on what they believe they are witnessing. The pertinent question then shifts from whether these observers are fabricating their accounts or experiencing hallucinations, to whether they are interpreting ambiguous data through the prism of their own expectations and a desire to uncover anomalies. The broader context becomes pertinent here. In early 2025, reports surfaced detailing a highly classified United States military assembly convened at Quantico, involving high-ranking generals and personnel from the Naval Radio Telescope facility. The officially disseminated narrative, to the extent that any coherent story has emerged, suggests routine briefings concerning space weather phenomena and solar-related threats. However, the timing of this meeting is highly suspect. It transpired immediately following the most intensive period of observations of 3i Atlas. The assembly included operators of radio telescopes, individuals who would possess access to non-optical data concerning the object that remains unavailable to civilian astronomers. The presence of senior military leadership at this meeting suggests either an extraordinary level of concern or an exceptional degree of awareness. None of this constitutes definitive proof of anything. None of this confirms the artificial nature of the objects in question. However, neither can it be dismissed as mere coincidence. It is an integral component of the emerging pattern. It represents another thread within the intricate tapestry that implies institutions are treating this phenomenon with a gravity that surpasses their public pronouncements. The significance of shape warrants further contemplation. In the natural world, most celestial bodies acquire their forms through undirected processes. Gravity aggregates material from all directions, resulting in predominantly spherical bodies. Solar winds sculpt tails. Outgassing generates jets. These phenomena produce shapes that, while complex, fundamentally arise from symmetrical forces. Conversely, engineered constructs, objects deliberately fabricated, tend to exhibit different characteristics. They display angles. They feature repeating geometric patterns. They present configurations optimized for specific functional purposes. They manifest design. When observers report identifying stingray-like shapes and pyramidal formations within images of 3i Atlas, they are posing the fundamental question: does this object exhibit the hallmarks of an engineered structure or a naturally occurring celestial body? The available data, being excessively pixelated and noisy, precludes absolute certainty. However, the patterns reported are remarkably consistent across multiple observers, rendering their dismissal as mere hallucination improbable. We're now entering a domain where attaining truth necessitates superior data, images of higher resolution, and more intensive observation. And as we transition from what is directly discernible to an understanding of the object's potential actual functions, we must confront the distinct possibility that 3i Atlas is not traversing the cosmos in isolation, but rather is accompanied by entities travelling alongside it for a specific purpose. Part 6. Guardians or Assassins. The three celestial bodies documented by Tiago preceding the solar eruptions invite a question that borders on science fiction, until one recalls that these objects are demonstrably real, recorded in official data, and defy every existing model we possess for phenomena occurring in near-solar space. If these accompanying objects are indeed travelling with 3i Atlas deliberately, if they are somehow affiliated with it, or exerting control over it, then what is their objective? What is their purpose? Tiago himself has posited the notion that they might be companions, perhaps fulfilling a specific function relative to the primary body. But what precisely would that function entail? The most readily apparent interpretation suggests protection. It is conceivable that these are guardian entities positioned to defend 3i Atlas from some unspecified threat, to shield it from a danger inherent in its passage through the inner solar system. The analogy of an escort emerges quite naturally. Military convoys deploy defensive elements to surround valuable cargo. They position offensive assets to establish a perimeter. They maintain constant vigilance against external threats. If a comparable scenario is unfolding here, then 3i Atlas represents valuable cargo, sufficiently important to warrant protection. It is significant enough that whatever intelligence dispatched it is willing to deploy multiple additional objects to ensure its safety. However, this constitutes but one interpretation. The inverse interpretation holds equal plausibility. What if these companion objects are not guardians, but rather aggressors? What if their positioning is intended not for protection, but for destabilization? What if they are actively working against 3i Atlas, incapacitating it, or manipulating its trajectory as it traverses our solar system? Within this hypothetical framework, the solar eruptions transform into a weaponized event. The companions would be leveraging the sun's inherent magnetic field and energy against their target, instigating coronal mass ejections and directing them with exacting precision. This presents a startling image, yet it is no more extraordinary than the concept of protective escorts. Both scenarios are speculative. Both are predicated upon limited data. Both prompt the identical inquiry. Are we observing a cosmic convoy or a cosmic conflict? Are we witnessing the initial maneuvers of an interstellar dogfight that has extended into our solar system, with the sun itself serving as the arena and 3i Atlas positioned as either the prize or the target? The hypothesis concerning the deliberate triggering of solar eruptions becomes empirically testable if we engage in careful consideration of its potential mechanics. If the companion objects are indeed actively initiating these eruptions, we would anticipate the observation of recurring patterns. We would expect to witness a strengthening of correlation as the objects draw nearer to and subsequently past the sun. We would anticipate temporal correlations too precise to be dismissed as coincidental, exhibiting clear evidence of deliberate targeting. We would expect to observe asymmetries in the eruptions, perhaps preferentially occurring in solar surface regions where the companion objects traverse. Tiago's observations have indeed documented elements of this phenomenon. The triple cannibal coronal mass ejection, forecast for late January 2025, exhibited precisely the kind of temporal correlation that would be expected if external entities were actively inducing the eruptions. However, 3 data points are insufficient to establish a conclusive pattern. Further observations are imperative. Time is required to monitor the behavior of 3I Atlas as it continues its trajectory towards perihelion, its closest point of approach to the Sun. The precise mechanism by which such triggering might be accomplished warrants consideration, even if purely speculative. Solar magnetic reconnection is an inherently dynamic process. The Sun's magnetic field is in a perpetual state of reconfiguration. Tensions gradually build, energy accumulates, and release events are an inevitable consequence. However, the precise timing and spatial location of these releases are dictated by complex dynamics that remain imperfectly understood. Now, imagine an external entity, an object possessing an unusual electrical charge or a unique composition, approaching the solar surface. Its presence within the Sun's magnetosphere could precipitate localized disturbances. It could induce shifts in the local field topology. It could provide the decisive impetus that transforms stored potential energy into kinetic energy, precipitating an eruption that was, in essence, inevitable, but whose exact temporal and spatial occurrence would have differed in the absence of such external perturbation. This is not mystical. This is not technology beyond comprehension. This is simply the application of established physical principles. However, it necessitates a profound understanding of solar dynamics, remarkable precision in navigation, and the technological capacity to approach the Sun itself without succumbing to its extreme environment. Any civilization possessing such capabilities would be centuries, if not millennia, in advance of our own. The skeptical counterargument rightly emphasizes the formidable energy budget challenges. To reliably induce solar eruptions with an object substantially smaller than a major celestial body, one would require the application of immense energy. This would necessitate directed energy beams of astonishing power or gravitational manipulation far beyond our current theoretical frameworks. It would imply technology so advanced that the very notion of deploying it to merely trigger eruptions seems almost gratuitous, akin to utilizing a thermonuclear weapon to ignite a candle. And yet, this line of reasoning is predicated on speculation built upon further speculation. We lack concrete evidence that solar eruptions are being deliberately induced. We have observed correlations. We have identified temporal patterns. We have noted the presence of objects concurrent with the occurrence of eruptions. This does not constitute definitive proof. However, it represents precisely the type of evidence that demands rigorous investigation rather than the prevailing institutional silence. As the questions surrounding the motivation and mechanism of 3I Atlas persist, another pattern begins to emerge, suggesting that this particular comet is not an isolated anomaly. Other comets exhibiting a green luminescence are currently present in our skies, and they too are behaving in unusual ways. Part 7. The Silence of the Green Comets. In the month since 3I Atlas made its appearance and began to exhibit its catalogue of irregularities, other comets have graced our celestial view. These are not random interlopers. They are sufficiently proximate to be discernible by naked-eye observers and those utilizing binoculars. They emit a characteristic green glow, a phenomenon attributed to diatomic carbon molecules within their comas, the illuminated cloud of gas surrounding the nucleus. Comet C20-25 A6. Lemon arrived from the distant reaches of the solar system. Comet C20-25 R2 Swan commenced its approach. Comet C20-25 K1 Atlas, bearing the same designation as the automated telescope system, joined this celestial gathering. These are essentially the overlooked relatives of 3I Atlas, and they have garnered minimal attention despite their proximity to Earth and their visibility to casual stargazers. Coverage within astronomical media outlets has been notably sparse. Discussions within mainstream scientific discourse have been virtually non-existent, and when one juxtaposes the reporting on these other comets with the attention directed towards 3i Atlas, a curious pattern emerges. The focus intensifies, resources become concentrated, attention converges upon the object exhibiting the most pronounced anomalies, leaving the others in relative obscurity. This might be interpreted as entirely natural scientific prioritization. 3i Atlas is, by all accounts, the most anomalous object. Therefore, it logically commands the greatest share of attention. Scientists operate under constraints of limited time, funding, and resources. Prioritization is an unavoidable necessity. It stands to reason that the most intriguing case would receive the most thorough study. However, it is precisely the silence surrounding these other green comets that renders the situation particularly noteworthy. Some of them are displaying peculiar behaviors. Several are exhibiting unexpected emission lines. Some are demonstrating anomalous variations in their brightness. Several are exhibiting tail orientations that deviate from predictions based on solar wind pressure models. None of this, individually, constitutes definitive proof of an unnatural origin. None of it presents unambiguous evidence of non-natural provenance. However, when considered collectively across multiple objects arriving simultaneously from outer space, the emergent pattern strongly suggests an avenue worthy of investigation. Are these comets simply naturally more exotic than is typical? Are we witnessing a rare cohort of unusual, albeit natural celestial bodies? Or might they serve as decoys? Could they be accompanying probes? Are they part of a larger fleet adhering to a deliberate itinerary? The dichotomy between institutional suppression and selective scientific focus becomes relevant here. In any academic discipline, certain topics attract funding and attention, while others languish in relative neglect. This is partly driven by merit. The most compelling questions naturally solicit investigation. However, it is also influenced by political considerations. Inquiries that challenge established paradigms, that provoke discomfort, or that carry profound implications for our understanding of the universe, sometimes fail to receive the attention they merit. Instead, they are met with institutional silence. Institutions develop implicit protocols concerning which questions are deemed acceptable and which are not, which researchers are permitted to pursue certain lines of inquiry without jeopardizing their careers, and which findings will be published and celebrated as opposed to those that will be filtered out. This is not an unsubstantiated conspiracy theory. It is a reflection of how institutions actually function. They possess inherent defense mechanisms akin to immune systems, which react against foreign elements that threaten their fundamental assumptions. When data emerges that contradicts these foundational assumptions, this internal immune response is activated. The comparative analysis we require is straightforward. We must ascertain whether any of the other green comets exhibit the pronounced negative polarization observed in 3i Atlas. We must examine their spectral analyses for anomalous chemical ratios. We must assess their morphological characteristics against our established models for natural comet shapes. We must search for evidence of companion objects within high-resolution imagery. We must correlate their approaches with solar activity. If we discover that multiple comets display a similar constellation of anomalies, then we will have transitioned from a singular mystery to a discernible pattern, and patterns inherently point towards causes. Causes in turn demand thorough investigation. Conversely, if we find no unusual characteristics in the other comets, then 3i Atlas becomes even more remarkable and considerably more challenging to explain solely through natural processes. Regardless of the outcome, the investigation should proceed. Regardless of the findings, the prevailing silence surrounding these objects should cease. Yet, it has not. And the longer this silence persists, the more we are compelled to question whether something else is unfolding beneath the surface. Something coordinated, something that extends across all these comets simultaneously, suggesting a singular organizing principle. Perhaps they are interconnected by a grander cosmic design. Perhaps they are not random visitors at all. Part 8. the solar trigger hypothesis. The Sun is not a quiescent entity. It is a tumultuous dynamic engine of nuclear fusion, enveloped by a magnetic field of astonishing complexity. Coronal mass ejections are violent occurrences wherein the Sun's magnetic field undergoes catastrophic reconfiguration, expelling billions of tons of plasma into space. The underlying mechanism is understood in broad terms, yet remains enigmatic in its specifics. We comprehend that magnetic reconnection, the rapid rearrangement of field lines, is the catalyst for these explosive events. We recognize that tension accumulates within the magnetic field and is subsequently released in sudden cascades. We are aware that the temporal scale of these releases can range from hours to mere seconds. However, we do not fully grasp what initiates a specific eruption at a precise moment. We lack the ability to predict them with accuracy. We cannot control them, or at least we, as humans, cannot. But something else might possess that capability. The empirical possibility is conceptually direct. As 3I Atlas and its accompanying entities approached the Sun, there was a discernible increase in the frequency and intensity of solar eruptions. This correlation is evident within the available data. The critical question is whether this correlation implies causation. Causation necessitates more than mere correlation. It requires a plausible mechanism, an understanding of how event A leads to event B. In this context, how could external objects approaching the Sun instigate eruptions? One conceivable avenue is electrostatic induction. Every object in space possesses a degree of electrical charge, representing either an accumulation of electrons or a deficit relative thereto, relative to a neutral state. When a charged object enters the Sun's magnetosphere, its electrical field interacts with the solar field. This interaction can generate localized disturbances, areas where the field topology undergoes alteration. These disturbances can propagate outwards, potentially interacting with existing tensions within the magnetic field, and could serve as the ultimate trigger that converts stored potential energy into kinetic energy, thereby initiating an eruption. Another potential mechanism involves gravitational disturbance. While the gravitational influence of smaller objects is typically negligible, it is not entirely absent. A compact, dense object approaching the Sun could generate gravitational waves or gravitational perturbations that ripple through the solar interior and corona. These perturbations could disrupt the configuration of energy accumulated within the magnetic field, subtly shifting the delicate balance. This shift could be just sufficient to trigger an eruption that was already poised to occur. A third possibility, more speculative but nonetheless worthy of consideration, involves directed energy beams. Should an external object possess the capacity to generate high-energy photons or particles and precisely direct them, it could potentially manipulate the solar magnetic field directly, or initiate specific reconnection events through targeted energy application. Examination of historical correlations is warranted, even if the available data is incomplete. Past astronomical records do indicate instances where smaller bodies passed in close proximity to the Sun, followed by unusual solar activity. However, historical records are inherently imprecise and incomplete. Establishing causation from such data is unreliable due to poor data quality and the prevalence of confounding variables. Modern observations offer greater precision. Nevertheless, modern observations pertaining to 3I Atlas are limited to the past few months. The dataset is presently too limited to establish statistical significance. We require additional time. We necessitate further observations. We need 3I Atlas to attain perihelion and complete its passage, thereby affording us the opportunity to observe whether the correlations persist, whether they intensify, and whether they exhibit patterns consistent with deliberate targeting rather than random natural variation. The triple conjunction of coronal mass ejections, predicted for the latter part of January in the year 2025, signified the arrival of 3 distinct solar outbursts at Earth in rapid succession. Such an occurrence is exceptionally uncommon, markedly dramatic and invariably captures public interest. Tiago meticulously recorded that each of these eruptions coincided with the passage of one of his 3 celestial companions. The pertinent question arises, is this mere chance, or is there a causal relationship? The statistical likelihood, as we previously discussed, is exceedingly remote, yet an extraordinarily low probability does not equate to definitive proof. A skeptic can always revert to the stance that an improbable event transpired and that we are unable to conclusively dismiss the role of chance. While technically accurate, this perspective also presents a logical framework that could be employed to dismiss any observed correlation, regardless of its precision, as purely coincidental. The verifiable prediction for this scenario is as follows. As the object 3i Atlas continues its trajectory towards the Sun, we should anticipate an escalation in solar activity. Should the hypothesis of a solar trigger be accurate, we would expect to witness eruptions that correlate with the passages of these companion objects, exhibiting a timing so exact that it defies random occurrence. Conversely, if solar activity reverts to its normal background levels, if no discernible link between the passage of companion objects and solar eruptions is observed, or if the solar system responds to 3 Atlas precisely as it would to any other comet, then the solar trigger hypothesis is invalidated. It is susceptible to empirical observation and is therefore falsifiable, which is the very essence of its scientific significance. However, transitioning from the solar trigger hypothesis to its broader implications necessitates an examination of the human and institutional factors that contribute to these inquiries being posed by amateur astronomers and independent researchers, while the established scientific community maintains a calculated distance. Part 9 delves into bias, ego, and gatekeeping. Science, as a human endeavour, inevitably carries the inherent frailties of individuals into the institutions they construct. We tend to romanticize science as operating in a detached realm, uninfluenced by politics, personal ego, or self-interest. We cultivate a narrative wherein scientists are solely dedicated to the pursuit of truth, where the most meritorious ideas prevail exclusively on their own merits, and where data unequivocally dictates understanding and institutions readily heed its message. This idealized perception, while comforting, is largely an illusion. The academic landscape operates under incentive structures that prioritize career advancement over the unvarnished truth, that value publications in prestigious journals above meticulous investigation, and that encourage adherence to existing orthodoxies rather than challenging fundamental assumptions. A young scientist aspiring to build a career may refrain from posing questions that could antagonize funding bodies or influential senior colleagues. A researcher who has established their reputation upon a specific theory may be disinclined to welcome evidence that contradicts it. An institution possessing significant capital, prestige, and established paradigms may be reluctant to embrace data that undermines those very paradigms. These are not indicative of a flawed version of science. Rather, they are characteristic of human behaviour when individuals coalesce into organisations and establish hierarchies of power. The framework utilised by researchers for evaluating risks in their investigations is known as Type 1 and Type 2 error analysis. A Type 1 error, or a false positive, occurs when a conclusion is drawn that something is real when it is not. A Type 2 error, or a false negative, is the failure to detect something that is genuinely present. Science has been systematically conditioned to fear Type 1 errors. Our institutions have been designed to minimize the risk of falsely claiming a discovery. It has been made easier to overlook something real than to erroneously announce something false. This approach is sensible in contexts where false positives carry substantial peril. If a medical treatment is erroneously deemed effective, lives can be lost. If a structural engineering solution is mistakenly certified as sound, buildings can collapse. However, in the realm of fundamental research, when pursuing understanding of profound questions about our place in the cosmos, this asymmetry becomes problematic. it becomes more expedient to disregard anomalies than to investigate them, and more comfortable to maintain silence than to pose challenging questions. Dr. Hosenfelder's observations on this tendency are pertinent. She has highlighted that institutional pressure to avoid embarrassment, to avoid being demonstrably incorrect about something as fundamental as the potential for artificial intelligence within our solar system, has fostered a system where Type 2 errors are far more acceptable than Type 1 errors. We readily accept the possibility of missing a first contact rather than risking the premature announcement of such an event. Historical precedents underscore this pattern. When exoplanets were initially discovered, mainstream astronomy largely dismissed them. The supporting evidence was compelling, and the methodologies employed were sound, yet the implications so thoroughly challenged established models that the initial reaction was skepticism bordering on outright hostility. It took years for the scientific community to acknowledge that planets orbiting other stars were not only plausible, but in fact inevitable. More recently, the study of unidentified aerial phenomena has faced such pervasive institutional suppression that many researchers are hesitant to engage with the topic. Military pilots, commercial airline crews, and trained observers have reported phenomena that are anomalous, that surpass known aerospace capabilities, and that warrant investigation. Nevertheless, the scientific community maintained for decades what can only be described as a conspiracy of silence. There was no official inquiry, no allocation of institutional resources, and no acknowledgement that the question merited consideration. Only when military leadership itself declassified information and mandated an official investigation did academia grudgingly begin to participate. Even now, this engagement remains minimal, with sparse resources and a persistently dismissive rather than curious tone. The human element of gatekeeping cannot be overstated. Scientific journals are overseen by editors, and editors possess their own opinions. These editors make decisions regarding which papers warrant publication and which do not. These judgments are ostensibly filtered through a peer review process, intended to be objective, where experts assess the merits of research. However, peer review is conducted by individuals who have established reputations, who adhere to existing theories, and who have vested interest in particular paradigms. A manuscript proposing that 3 Atlas might be artificial would likely encounter skepticism from reviewers whose careers are predicated on understanding comets as purely natural phenomena. A paper detailing anomalous polarization would be subjected to far more rigorous scrutiny than one describing expected polarization patterns. This system is not inherently designed to deliberately suppress truth. Rather, it is structured to maintain quality control. However, in practice, this results in heterodox ideas facing greater obstacles to publication than orthodox ones. Revolutionary findings undergo more skeptical review than incremental advancements. Within this environment, the most straightforward path to career success involves posing safe questions and arriving at safe answers. What garners attention, and the reasons behind it, ultimately boil down to a matter of institutional politics and the momentum of prevailing culture. When a discovery aligns with established paradigms, it attracts resources. Conversely, when a discovery contradicts existing paradigms, it invites caution, and sustained caution often devolves into obstruction. The corollary to this is that significant anomalies can become buried under the weight of institutional inertia. They do not vanish. They remain present in the data, accessible to anyone with the capacity to discern them. However, they fail to receive the attention they deserve, the resources they warrant, or the thorough investigation they require, because such an investigation would necessitate admitting that our current understanding is fundamentally flawed. Such an admission is uncomfortable. It implies a re-evaluation of careers, a reconsideration of research accumulated over lifetimes, and an acknowledgement of past errors. These are challenging propositions for both institutions and individuals. Consequently, silence is maintained. The hope is that anomalies will dissipate, that another party will undertake their study, thereby absolving oneself of the responsibility. The wish is that by ignoring them long enough, they will cease to be disconcerting. However, there exists another layer to this institutional response involving classified information and data compartmentalization. Government agencies possess access to satellite data, observational platforms, and sensor arrays that far exceed the capabilities available to civilian scientists. The military tracks objects in near-Earth space with a precision that amateur astronomers cannot match. Intelligence agencies monitor solar activity and coronal mass ejections with a sophistication that public sources do not provide. If 3i Atlas and its companions represent something genuinely anomalous, something genuinely concerning, then governmental entities are aware of it. They possess knowledge before the civilian astronomical community does. They hold detailed information that is not publicly disseminated. They have raw data, real-time observations, and sensor streams that remain classified. When they elect not to disclose this information, when they maintain silence, they create a situation where civilian scientists are compelled to work with incomplete data, rendering them incapable of reaching firm conclusions because they are literally denied access to the most critical information. It is akin to attempting to solve a complex puzzle with half the pieces locked away. This is not a matter of conspiracy theory. It is a reflection of how governments operate. They compartmentalize, they classify, and they withhold information from the public and from civilian researchers. The fundamental question is not whether this is occurring, but rather what information they possess and the rationale behind its secrecy. When one combines the institutional pressures within academia, the incentive structures that reward caution, the career risks associated with posing heterodox questions, and the gatekeeping mechanisms of publication with the classified information held by government agencies, a perfect environment is created for the suppression of genuine discoveries. The anomalies persist, the data endures, but the investigation remains incomplete, the discourse muted, and the public uninformed. Gradually, these uncomfortable truths recede beneath the surface of public consciousness. They do not disappear, they simply transform into the kind of phenomena that people vaguely acknowledge exist but seldom discuss. The kind of thing visible in data but unacknowledged through official channels. This is the function that institutional silence fulfills. It is not born of ignorance, but is an active suppression masked as prudence, a defense of existing paradigms at the expense of uncovering truth. Once the inner workings of this system are understood, the incentive structures, the gatekeeping, the compartmentalization, one cannot help but ponder what else has been relegated to the archives of institutional inertia. What other phenomena, visible in our data, have remained invisible in our discourse? What other first contacts have we failed to recognize, either due to a lack of attention or an active choice to avert our gaze? Part 10 examines the debate surrounding alien technology, Reloaded. Avi occupies a unique position within the astronomical community. He possesses credentials, his work is published, and he is respected. Crucially, he is willing to pose questions that others shy away from. His research, specifically investigating whether 3i Atlas could be indicative of artificial technology, is published on the AHA-Civ preprint server, a platform where scientists share their research both before and during the peer review process. The paper's title is the Interstellar Object 3 Atlas Alien Technology. The mere existence of this paper, authored by a scientist of considerable standing and disseminated through legitimate academic channels, signifies a pivotal moment. The question is no longer confined to fringe speculation. It is now part of the academic record. Future researchers will be compelled to cite and address it. Subsequent textbooks, future students, and future scientists will be aware that this possibility was seriously considered by a credible expert. This holds significance beyond immediate perception. Once a question has been articulated and seriously considered within academic literature, it cannot be unasked. It becomes an indelible part of the historical record, a subject that necessitates engagement rather than dismissal. The dark forest hypothesis, first proposed by Liu Cixin in his science fiction trilogy, and subsequently adapted as an analytical framework by researchers examining scenarios of cosmic contact, offers a context for understanding why artificial objects might traverse our solar system without announcement. The core premise posits that the universe is inherently perilous. Civilizations that reveal themselves risk annihilation by more advanced civilizations, or by those who perceive them as threats. The logical response to such danger is to conceal oneself, to maintain silence, and to refrain from broadcasting one's existence. A probe or object journeying through interstellar space might be doing so precisely out of caution, remaining undetected, minimizing energy signatures and communication. It could be engaged in reconnaissance, gathering intelligence about our civilization without revealing its presence. Alternatively, it might be a passive observer, meticulously recording and studying without any intention of initiating communication. From this viewpoint, the presence of 3i Atlas and its companions within our solar system aligns perfectly with what one would expect from a cautious civilization initiating first contact. They would dispatch probes before sending crewed vessels, observe before communicating, and prioritize risk mitigation while acquiring information. By this logic, the very stealth of the approach and the minimalist nature of the encounter serve as evidence supporting the hypothesis of an intelligent presence. The counter-arguments from skeptics are formidable and warrant serious consideration. Fragmentation is a well-documented phenomenon in cometary science. Large celestial bodies traversing space are subjected to impacts, tidal forces, and thermal stress, leading to their disintegration and the creation of multiple fragments travelling along similar, though not identical, trajectories. Could the three companion objects simply be fragments that detach from 3i Atlas during its transit? The answer is affirmative. This is a plausible scenario. However, fragmented debris does not typically exhibit coordinated timing in relation to solar eruptions. Fragments do not trigger simultaneous events, nor do they display evidence of deliberate positioning. While the fragmentation hypothesis can account for the existence of multiple objects, it struggles to explain the precise timing, the triggering of eruptions, and the apparent coordination of activity. Dust jets represent another natural phenomenon. Comets outgas, producing jets of material that can appear as distinct objects in optical imagery. Could the companions be massive dust jets emanating from 3i Atlas itself? Perhaps. But dust jets do not trigger solar eruptions, nor do they exhibit the types of trajectories that have been documented. Furthermore, dust jets do not maintain stable positions relative to solar activity. Instrumentation errors must always be considered. The SOHO instruments have been operational for decades, generating millions of images, most of which are unremarkable. However, the potential for systematic errors, calibration issues, or artifacts in data processing is never entirely absent. Could the three observed objects be instrumental artifacts, mere creations of the data processing pipeline rather than genuine physical entities? Technically, this is possible. However, these same objects have been detected by multiple independent observers utilizing different equipment and methodologies. If this were an instrument artifact specific to SOHO, it would not manifest in images from other observatories. Yet, numerous amateur astronomers have documented similar anomalies, multiple telescopes have captured related data, and various data streams converge to indicate something real, something physical, present in near-solar space. The instrumental error hypothesis would necessitate a highly improbable, coordinated failure across multiple independent observation systems. While possible, this scenario requires a significantly higher probability than the hypothesis of a genuine physical entity being present. Hybrid models also warrant consideration. A probe coated to resemble a comet could combine characteristics of both natural and artificial objects. Such an object might display some spectroscopic signatures consistent with normal cometary material, while simultaneously exhibiting anomalies suggestive of artificial engineering. It could possess natural ice and dust surrounding its core systems. The polarization anomalies might then reflect the presence of engineered surfaces beneath a natural exterior. The chemical anomalies could indicate intentional processing of materials for specific purposes, and the shape anomalies might reveal an underlying structure masked by a superficial coating. Within this model, 3i Atlas would be neither purely natural nor purely artificial, but rather a hybrid object designed to appear natural while serving engineering objectives. This is the kind of possibility that keeps researchers like Lowe engaged and makes the question profoundly important to investigate. For if this model proves correct, we might be on the cusp of one of the most significant discoveries in human history. Even if it is incorrect, and 3 Atlas is indeed a perfectly natural, albeit unusual, comet, we will still have gained valuable insight. We will have established that our current models and theories are insufficient to explain this particular object, demonstrating that nature is more surprising than we had anticipated. Regardless of the outcome, the investigation itself holds considerable value. The scenario ranking serves as a framework for clear probabilistic thinking. Scenario 1 posits that 3i Atlas is a naturally occurring comet with unusual but explicable characteristics. According to Lowe and other researchers willing to seriously engage with the anomalies, the probability of this scenario is approximately 30 to 40%. Scenario 2 suggests that 3i Atlas is a comet characterized by dust and gas outgassing, with its anomalies explained by its composition rather than artificiality. The probability for this scenario is estimated to be roughly 20 to 30%. Scenario 3 proposes that 3i Atlas is a probe or engineered object designed to mimic cometary appearance. The probability assigned to this scenario is approximately 15 to 25%. Scenario 4 encompasses a combination of these possibilities, or an as yet unconsidered alternative. The remaining probability is allocated to this category. When a credible expert assigns a meaningful probability to the possibility of an artificial origin, particularly when that probability rivals or surpasses that of some natural explanations, it signifies a question of genuine importance. This is not due to any certainty of alien presence, but because the evidence demonstrably does not rule it out. The anomalies are real, the correlations are significant, and the questions merit thorough investigation. However, this investigation is not proceeding at the scale and intensity it ought to, and the mainstream scientific community remains silent on the reasons why. Now, we must broaden our scope beyond 3i Atlas itself to determine whether similar patterns of anomaly and hidden signals manifest elsewhere in the cosmos, whether 3i Atlas is an isolated phenomenon or one instance of a broader, more unsettling cosmic pattern. Within sophisticated computational models of the early universe, researchers are exploring a possibility that would have been considered pure fantasy mere years ago: dark stars. These are not stars that are simply dim due to low-light generation, but rather stars fundamentally powered by mechanisms other than nuclear fusion, deriving energy from the annihilation of dark matter particles, or from other exotic processes not yet fully comprehended by conventional physics. Such objects would have formed in the initial moments following the Big Bang, when the universe's extreme density facilitated the accumulation of dark matter particles in stellar cores to a far greater extent than is observed today. Under those primordial conditions, ordinary matter and dark matter would have been intimately mingled, creating environments drastically different from anything observed in the modern universe. The gravitational contraction that initiated the formation of the earliest protostars would have sequestered immense volumes of dark matter within their central regions, thereby establishing conditions conducive to dark matter annihilation. This process could have fueled stellar luminosity long before conventional nuclear fusion commenced. Consequently, a dark star would possess an exceptionally extended operational lifespan, potentially extending for billions of years beyond that of conventional stars. The underlying reason for this remarkable longevity is intrinsically linked to its unique energy generation mechanism. Nuclear fusion in ordinary stars depletes its hydrogen fuel at rates dictated by the prevailing temperature and pressure within the stellar core. In contrast, dark matter annihilation functions through an entirely different paradigm. As dark matter particles accumulate within the star's gravitational potential well, they would undergo continuous annihilation, providing a consistent and sustainable energy output that could persist far longer than any fusion-based reaction. This prolonged existence would have profound implications for the evolutionary trajectory of stars, possibly permitting certain dark stars to endure from the universe's nascent epochs right up to the present day. Such objects would radiate at lower intensities compared to conventional stars, while simultaneously containing prodigious quantities of concealed energy within their interiors. The energy liberated through dark matter annihilation would elevate the temperature of the surrounding stellar material, prompting it to emit radiation, although the overall luminosity might be subdued when contrasted with stars of comparable mass powered by fusion. The spectrum of radiation emitted would likely be unconventional, potentially exhibiting emission lines and continuum features that deviate from established stellar models. To an observer, such an object might present as a faint, unremarkable entity, perhaps misclassified as a brown dwarf or a stellar remnant that failed to ignite. It could well be registered in our astronomical databases simply as another cool stellar remnant or substellar object, having been overlooked and deemed unremarkable. Yet, concealed beneath its exterior, imperceptible to standard observational techniques, it would represent a formidable source of energy and complexity, operating according to principles that challenge our current comprehension of stellar physics. A careful consideration of its appearance to our telescopes and instruments is warranted. A dark star would display anomalous spectral characteristics when compared to normal stars of similar dimensions and temperatures. Expected absorption lines might be absent or shifted. Emission features could manifest in regions where their presence is theoretically impossible. Its luminosity would not align with predictions based on its mass. The universally reliable mass-luminosity relationships that accurately describe ordinary stars would prove inadequate. Its evolutionary path would deviate from expected trajectories. Where we anticipate a star to have depleted its fuel and subsequently collapsed or cooled, a dark star might continue radiating. Its temperature gradient would exhibit peculiar characteristics. The interrelationship between core temperature, surface temperature, and luminosity would diverge from theoretical predictions. Essentially, it would remain largely undetectable by many of our observational methodologies, while simultaneously exhibiting attributes that do not conform to our conventional stellar models. The inherent difficulty is exacerbated by the potential rarity of dark stars. If their formation was predominantly confined to the early universe, their population would be constrained by the specific conditions necessary for their inception. Identifying them necessitates more than a mere search for anomalies. It requires discerning which anomalies are significant and which represent mere measurement inaccuracies or instrumental artifacts. Scientific publications from the year 2025 have put forth specific candidate objects for dark star identification and have modelled the potential detectability of these entities with forthcoming telescope generations. The James Webb Space Telescope, owing to its exceptional infrared sensitivity, might prove capable of identifying candidates by scrutinizing their unusual spectral properties. Subsequent astronomical surveys could systematically search for objects whose characteristics are inconsistent with established models. The theoretical framework supporting the existence of dark stars is progressively becoming more robust. Astrophysicists have formulated detailed predictions regarding their appearance, evolutionary patterns, and detectable signatures. While the practical challenge of their identification remains significant, it is by no means insurmountable. And it is precisely at this juncture that the parallel to the three-eyed atlas becomes strikingly pronounced and unsettling. Reflect upon our accumulated knowledge regarding the three-eyed atlas. It possesses an intrinsic concealed energy source, whether of natural or artificial origin. Its observable characteristics do not align with our standard models for cometary behavior. It exhibits anomalies in its polarization, chemical composition, and morphology, strongly suggesting that its underlying nature is fundamentally different from what we would expect. In essence, it represents a cosmic enigma cloaked within the guise of a seemingly ordinary comet. Similarly, a dark star in many respects is a cosmic enigma concealed within the appearance of a conventional stellar object. The parallel is not absolute, yet the underlying principle remains identical. In both scenarios, we are confronted with objects that superficially present as one entity, but potentially harbour something far more complex and unusual beneath the surface. The investigative methodologies employed for both object types share common elements. Rigorous spectroscopic analysis, continuous monitoring of temporal variations in brightness and composition, and diligent searches for deviations from anticipated behaviour are all crucial. The recognition that anomalies, when they occur in clusters rather than in isolation, may signify something genuinely novel, rather than mere observational error, is paramount. This confluence of discoveries, dark stars being proposed as plausible astrophysical phenomena precisely when the three-eyed atlas presents the most remarkable anomalies, elicits an unsettling query. How numerous might dark stars be within our galaxy? Current estimates span a wide spectrum, ranging from none to potentially thousands, contingent upon the assumptions embedded within formation models. How many objects currently catalogued as ordinary stars or brown dwarfs might, in reality, be something far more extraordinary? Our stellar catalogues comprise millions of entries, with the majority observed only briefly and classified based on limited data. Systematic surveys are primarily designed to identify objects conforming to expected categories. Those that deviate substantially might be relegated to the status of measurement errors rather than being recognised as genuine discoveries. Furthermore, if dark stars are capable of existing and operating via concealed energy sources, could a similar principle apply to smaller celestial bodies? Once the concept of hidden power sources is established at the stellar scale, it becomes more difficult to dismiss its potential at planetary, asteroidal, or cometary scales. Could artificially constructed objects masquerade as natural bodies by employing energy sources and power systems that elude our conventional observational methods? The implications expand dramatically when one considers that artificial technology, sufficiently advanced, might operate according to principles currently beyond our comprehension. A civilization possessing the capacity for interstellar travel, capable of dispatching probes across vast interstellar distances, would undoubtedly possess power systems and energy sources that surpass our current understanding of physics. They might harness dark matter, as hypothesized in dark star models. They could exploit vacuum energy, quantum phenomena, or dimensional geometries yet to be theorized. Their operational methods might appear unremarkable to our instruments simply because we lack the appropriate tools to accurately measure their activities. The existence of dark stars as genuine astrophysical entities, irrespective of their rarity, suggests that the universe encompasses greater complexity and more concealed processes than acknowledged by our conventional models. And if the universe is indeed more complex and more enigmatic than previously conceived, then the possibility that certain objects deliberately conceal their true nature becomes less preposterous and more intriguing. It is prudent to acknowledge the skeptical perspective regarding dark stars themselves. Observational data is inherently prone to noise. Alternative theoretical frameworks might adequately explain the observed phenomena without necessitating the invocation of dark matter annihilation or exotic energy sources. Conventional stellar physics, when appropriately refined, could potentially account for apparent anomalies. The case for dark stars remains speculative and incomplete, necessitating further observational validation before widespread acceptance. This is a fair critique. The scientific uncertainty is genuine, yet the very uncertainty itself carries significant weight. When mainstream astrophysics begins to propose exotic celestial bodies with concealed energy sources and extraordinary longevity, especially when such proposals are published in reputable journals and debated at major scientific conferences, we've entered a domain where the boundaries of possibility have expanded. We've conceded that the universe is more astonishing than our previous models depicted. We've acknowledged the existence of objects with characteristics that significantly deviate from our expectations. And once this admission is made, once we accept that anomalies in various fields of study represent potential realities rather than absolute impossibilities, the imperative to investigate the three-eyed atlas with increased rigour becomes undeniable. If dark stars can exist, why could not artificial probes? If the cosmos harbours objects with concealed engines at the stellar scale, why could not some of those objects be artificial constructs operating at smaller scales? The pattern of anomaly, once recognised as a legitimate phenomenon at the stellar scale, becomes progressively harder to dismiss at the cometary scale. The intellectual framework that accommodates the existence of dark stars logically creates space for contemplating other exotic possibilities, including the one that induces the greatest discomfort, that we are not alone, and that evidence of other intelligences might already be traversing our solar system, camouflaged as ordinary cosmic debris. Part 12. The AI Model Collapse Scare. Beginning in late 2024 and extending into 2025, investigators collaborating with expansive language models and other artificial intelligence frameworks started to document observations that would have been easily disregarded as fundamentally illogical mere years prior. Under specific duress, when their operational capacities were stretched to their utmost, or when subjected to unforeseen inputs that their developmental training had inadequately prepared them for, certain AI systems began exhibiting indicators of instability. These frameworks would generate unpredictable results that bore no logical relation to the input data provided. They would experience abrupt, catastrophic breakdowns, akin to a bridge succumbing to unforeseen strain. Some researchers characterize this as a collapse, a term typically associated with structural failures in engineering disciplines. This represented a devastating malfunction where the model transitioned swiftly from producing coherent responses to generating complete gibberish with minimal forewarning. The shift was not incremental. The decline was not discernible in advance. One moment the system performed as expected, the next it produced nonsensical output. This peculiar occurrence is not yet fully grasped by the scientific community investigating it. Some researchers attribute it to deficiencies in the training data, positing that the models never adequately acquire the ability to respond to particular categories of input. Others suggest inherent limitations in how these models process information at a grand scale, limitations intrinsic to the very design of the architecture. A few propose that the models are reaching computational boundaries beyond which they can no longer sustain coherent functionality, indicating a ceiling beyond which the established methodologies simply cease to be effective. Irrespective of the underlying cause or causes, the observable effect is remarkably uniform across diverse models, distinct architectures, and varied implementation strategies. Advanced artificial intelligence systems possess inherent limits. They harbour concealed modes of failure. They contain internal states and processes that remain beyond our complete comprehension. They can appear entirely normal and functional until an external factor precipitates a breakdown. Now, consider the relevance of this phenomenon to our overarching inquiry concerning the three-eye atlas and anomalies in general, and the implications become exceptionally striking. A system, whether organic or synthetic, biological or computational, mechanical or electromagnetic, possesses an internal state that is not perpetually accessible to external observers. A system can present a semblance of normalcy while internally enduring strain or malfunction. A system can maintain outwardly typical behaviour, projecting an image of steadfastness, until a specific threshold is breached, at which point it abruptly displays failure or atypical conduct. If the three-eye atlas or its associated artifacts represent sophisticated technology, if they are indeed autonomous probes or interstellar craft, then they too would possess internal states that are not discernible through our external monitoring. They would have operational parameters and thresholds that we are incapable of measuring directly. They would contain concealed processes and systems functioning beneath their perceptible surface. They might appear as one entity from a distance, while potentially being something entirely different in their internal reality. The breakdown experienced by artificial intelligence models thus serves as both a symbolic representation and a cautionary tale. It serves as a reminder that once advanced systems attain a certain level of complexity, they become unpredictable. They evolve into something enigmatic. They encompass behaviors and failure mechanisms that we are incapable of foreseeing or anticipating. They can appear stable right up to the precise moment they are not. They can seem to be functioning ordinarily while internally approaching a critical breaking point. The consequences for evaluating whether the 3i atlas is natural or artificial become profound and deeply unsettling. If the 3i atlas is indeed an artificial construct, a probe dispatched from another civilization, it would be subject to these very same principles. It would possess internal states that lie beyond our capacity for measurement. It would have operational parameters that remain inaccessible to our direct observation. We would essentially be navigating blindly, attempting to comprehend an advanced system relying solely on external observation, while being denied access to its internal architecture or operational logic. We would be striving to understand a computer system by merely observing its external outputs, completely unable to examine its underlying code or hardware. The triggering of solar eruptions within this context might signify a critical threshold event. It could represent the system transitioning from one operational state to another. It might indicate the initiation of a particular directive or the activation of specific subsystems. It could mark the precise moment when the system began actively engaging with its environment, rather than merely passively observing. From our external vantage point, we witness only the consequence. We observe the eruption. We note the escalation of solar activity. We meticulously document the timing, but we remain unaware of the preceding events, of the system's internal operations, or of what precipitated the transition from dormancy to activity. This mirrors precisely how we might observe the malfunction of an artificial intelligence system. We witness the output becoming incoherent. We see the system generating nonsensical responses. We do not necessarily comprehend what caused the internal transition. We recognize that a change has occurred, but we cannot see inside to understand the reason. We are limited to inference based on external manifestations. The broader caution conveyed by the artificial intelligence stability phenomenon is one of humility, a warning that we must regard with utmost seriousness. We are interacting with systems that are more intricate, more potent, and more astonishing than we initially conceived when we commenced their development. We're constructing entities that behave in ways we did not fully anticipate. We're working with technologies that exhibit hidden behaviors and unexpected failure modes. We have engineered systems that surprise us, that perform actions beyond our original expectations. If we are uncovering these revelations about systems that we ourselves have created, systems that we have designed, trained, and managed directly, systems whose code and architecture are entirely transparent to us, then what can we possibly assert about systems that evolved under entirely different circumstances, governed by distinct physical laws and constraints, and developed by intelligences potentially far surpassing our own? The answer is a humbling one. We can state very little with absolute certainty. We can maintain appropriate humility regarding what is conceivable. We can acknowledge that our conceptual models and theories are incomplete, and that our frameworks for comprehending reality are inherently limited. We can recognize that anomalies might signify something genuinely beyond our current understanding, rather than being mere instrument inaccuracies, statistical anomalies, or measurement noise. The possibility that the 3i atlas might represent advanced technology becomes not necessarily more probable in a statistical sense, but it acquires greater coherence, becoming more internally consistent within a paradigm that embraces complexity and hidden failure modes as fundamental characteristics of sufficiently advanced systems. A system capable of concealment, of operating beyond our perceptual range, and of harbouring internal processes that we cannot observe, shifts from the realm of the fantastical to that of the expected. And while we contemplate anomalies in Earth's orbital systems and artificial intelligence, while we ponder the hidden intricacies of advanced technology, we must also direct our attention to a specific phenomenon that has been quietly unfolding within space itself, a signal of unknown origin that adds another critical dimension to the developing pattern and connects all that we have discussed thus far. This leads us to part 13, the quantum satellite glitch. In late 2025, reports began to circulate regarding unusual phenomena detected by the Jiaomu quantum communication satellite, a sophisticated Chinese orbital system engineered to investigate the principles of quantum entanglement and quantum cryptography across vast continental distances. This satellite embodies the pinnacle of space-based quantum technology. It is designed to be acutely sensitive to exceptionally subtle photonic occurrences. It is calibrated to perceive individual photons and their quantum states. Essentially, it functions as an instrument capable of discerning phenomena that would remain imperceptible to conventional telescopes or space instruments. And this highly sensitive instrument began to detect something that defied all expectations: anomalous bursts of photons, unexplained interference within the quantum channels, and entanglement failures that could not be attributed to known space weather phenomena or orbital mechanics. These failures appeared to correlate with specific temporal and spatial occurrences. They exhibited patterns suggestive of deliberate action rather than random chance. The disparity between theoretical expectations and actual observations represents a dramatic divergence. Theoretically, the Jiaomu satellite ought to experience quantum channel disruptions linked to cosmic ray impacts, solar particle events, and other recognized sources of interference. Instead, it was encountering failures that did not align clearly with these known causes. The failures manifested and vanished in a manner suggesting an external signal, something intentionally modulating the quantum states of the photons being measured by the satellite. It is important to note that this discussion involves speculation regarding classified information. Official Chinese statements concerning the satellite are notably brief. The details being presented originate from unofficial leaks and reports. However, if these accounts possess any degree of accuracy, then we are contemplating a phenomenon that bridges the gap between astronomical anomalies, which we have been examining, and the domain of actual technological interference. We are considering the possibility that signals or manipulations might be occurring within Earth's orbit, impacting our most sensitive instruments and interfering with our most advanced technologies. The speculative link to cosmic anomalies like the Three-Eye Atlas commences with a straightforward query. If an interstellar probe, a highly advanced technological system, were approaching Earth, how might it endeavour to ascertain information about our technological capabilities? One potential approach would be to observe from a distance, as we have hypothesized regarding the Three-Eye Atlas. However, a more direct method would involve subtle interaction with our existing systems, introducing minor perturbations to induce small failures, thereby observing how our technology responds. The quantum satellite, with its sensitivity to minute phenomena, would precisely be the type of system capable of detecting such interactions. It would perceive glitches and anomalies that less sophisticated equipment might overlook. And if an extraterrestrial intelligence were deliberately assessing our systems, intentionally causing minor malfunctions to gauge our reaction, then the photon bursts detected by Jiaomu would represent exactly the kind of signature we would anticipate. This is purely speculative, but it is speculation grounded in a recurring pattern we've observed throughout this narrative. Anomalies occurring at multiple scales and across diverse domains, suggesting potential intentionality, are met with official reticence and explanations that struggle to fully account for the evidence. The alternative explanations for the quantum satellite glitches are numerous: space weather, cosmic rays, instrument calibration drift, detector noise, corruption during data transmission. Any number of conventional phenomena could potentially explain photon anomalies. The the prior probability that the satellite is detecting some form of unknown interference is low. It is far more likely that conventional explanations are sufficient. However, the pattern of anomalies across multiple systems, the coincidental timing with astronomical events involving the Three-Eye Atlas, and the consistency of the phenomena despite occurring within different technological contexts all suggest that something more might be unfolding. The boundary between evidence and paranoia can sometimes be indistinct. When individual anomalies are isolated, they are easily dismissed. However, when patterns emerge, when the same type of anomaly appears in multiple contexts, and when temporal correlations become too precise to be attributed to mere chance, then isolated anomalies transform into a potential signal, and once recognized, that signal becomes impossible to ignore. This brings us to one final anomaly, one additional layer of evidence, one more component of the pattern that links comets, satellites, and the very fabric of the universe itself. We must turn our attention to Antarctica, to the Ice Cube Observatory, and to signals that traverse through the Earth. This is part 14, Antarctica's Hidden Signal. At the South Pole, embedded deep within the Antarctic ice, scientists have constructed an observatory unparalleled on Earth. IceCube is not a telescope in the conventional sense. It does not observe light. Instead, it detects neutrinos, ethereal particles that pass through ordinary matter as if it were almost non-existent. Imagine a particle so elusive, so fundamentally indifferent to interaction with normal atomic matter, that trillions of them traverse your body every single second without leaving any trace, without causing any alteration, without you even being aware of their presence. These neutrinos originate from the Sun, from distant cosmic cataclysms, and from the residual radiation of the Big Bang itself, echoing through space billions of years after the universe's cataclysmic genesis. They interact minimally with normal matter, rendering them extraordinarily challenging to detect. However, when a neutrino, on a rare occasion, and I mean genuinely rare, collides with an atomic nucleus deep within the Antarctic ice, something remarkable transpires. The collision generates a minor cascade of secondary particles. This cascade of particles produces light, a faint glimmer through the ice, akin to a phantom leaving a trail. IceCube detects this light. Its sophisticated instruments precisely track the direction and energy of the original neutrino. From this information, scientists infer the neutrino's origin and the cause of its existence. The observatory has been continuously cataloguing neutrino events for years, compiling an ever-expanding record of the high-energy universe revealed through these ghostly messengers that most of us will never consciously acknowledge, continuously flowing through us, past us, and around us in an unending stream. And something peculiar, something genuinely anomalous, has surfaced in that catalogue. IceCube has detected upward-moving neutrinos originating from deep within the Earth. These are neutrinos that appear to emanate from beneath the detector and travel upwards through the Antarctic ice before being registered by the sensitive instruments. These upward-travelling events are significant, critically so, because they cannot be cosmic rays. Cosmic rays constantly bombard our planet from space, showering our atmosphere with high-energy particles. These cosmic rays produce secondary particles that generate the downward-moving neutrino signals that IceCube detects most frequently. This is expected and well understood. However, upward-moving neutrinos operate under entirely different principles. Upward-moving neutrinos cannot originate from cosmic rays. They cannot come from space. They must originate from something situated within or below the Earth itself. They must stem from a localized source, something present here, beneath our feet. In theory, terrestrial neutrino sources should be virtually non-existent at the energy levels that IceCube is detecting. This is a crucial point. The radioactive decay of elements within the Earth's crust naturally produces neutrinos, yes, but at significantly lower energies. The few upward-moving events that IceCube has detected at the specific energy levels, which which have been meticulously documented, do not conform to standard models of terrestrial neutrino production. They are too energetic, they are too consistent, they are too organised to be dismissed as mere random background noise. The specifics of these observations warrant careful consideration, as they form the bedrock of all subsequent analysis. The directional alignment of these events is remarkably consistent. Multiple upward-moving events appear to originate from similar positions on the globe, as if emerging from a concentrated source rather than being randomly scattered throughout the planet's interior. The energy levels are specific and uniform, not fluctuating erratically as random background noise would. The frequency of these events exhibits discernible patterns rather than a random distribution. When one constructs a detector of such sophistication, invests years of effort and millions of dollars in observation, accumulates data over extended periods, and observes patterns within that data that deviate from conventional models, the question of the signal's source becomes unavoidable. One plausible explanation is that our models of terrestrial neutrino production are incomplete. Perhaps we've overlooked a natural source, a mechanism we have yet to theorize. It is possible that we are missing some natural phenomenon that generates neutrinos at these energy levels through processes that remain beyond our current understanding. Another possibility is that conventional explanations suffice, and we are simply observing rare but natural events at the periphery of statistical distribution, outliers that will eventually find their place within broader models. However, another possibility, unsettling and speculative yet genuinely worthy of consideration, is that we are detecting something artificial. We are detecting a signal emanating from an intelligence located on Earth, beneath the Earth, or passing through it. We are detecting communication, operation, or some technological process that generates high-energy neutrinos as a byproduct of its functionality. This possibility might seem absurd until one recalls a unique property of neutrinos. This property is so distinctive that it fundamentally alters the calculus of possibility. Neutrinos pass through everything unimpeded. An electromagnetic signal can be blocked by simple shielding. A radio signal can be jammed or intercepted by determined adversaries. Wireless signals can be scrambled or disrupted. But neutrinos travel freely through planets, through stars, through any physical medium as if barriers do not exist. They interact so weakly with matter that the Earth is essentially transparent to them. If an advanced civilization intended to communicate or operate in a manner that could not be easily detected or intercepted, neutrinos would represent the ideal medium. They would traverse the Earth unimpeded, unblocked, and undetectable by conventional observation methods. They would be invisible to our standard equipment, requiring specialized instruments precisely like those employed by IceCube to even be registered. IceCube exists not because we were actively searching for such signals, but because we were investigating natural cosmic phenomena. We erected this observatory to comprehend the high-energy universe, and in doing so, we inadvertently created the perfect instrument to detect the very type of communication that an advanced civilization might employ. If the 3i Atlas is an artificial probe, if it carries on board technology, if it possesses methods of communication or operation that we have not yet grasped, then high-energy neutrino signals would be precisely what we might expect to detect as evidence of such technology. The probe could potentially communicate across the solar system utilizing this medium. It could operate systems that produce neutrino emissions as incidental effects of their power generation processes. It could transmit information encoded in patterns that our detectors, if sufficiently advanced, might be capable of decoding. The connections drawn between comets, satellites, and Antarctic observatories might seem like the product of an overactive imagination, the kind of wild speculation that conscientious scientists tend to dismiss. However, they all represent instances of the same underlying phenomenon. Anomalies appearing in contexts where we do not expect them, patterns emerging in data that should be random, and signals manifesting in locations where conventional science indicates signals should not exist. And all of this is met with institutional silence. All of it is explained away through increasingly elaborate naturalistic models that compel us to believe in ever more improbable coincidences. All of it demands thorough investigation rather than outright dismissal. The evidence is present. The data persists. The underlying structure is discernible across vast cosmic expanses and down to the fundamental quantum realm, stretching from solar phenomena to terrestrial events and the deepest planetary core. We stand at a critical juncture, a moment demanding the integration of these disparate observations, a time to draw together the disparate threads and perceive the grander design that encompasses celestial bodies, stars, artificial satellites, and indeed, the very fabric of existence. The era of confluence is upon us. Part 15, The Ultimate Convergence. The foundational elements of this entire chronicle can be distilled to a starkly simple summary. 3 celestial objects travelling in a synchronized configuration. 3 solar flares initiated in a meticulously timed sequence. An extreme negative polarization signature, inconsistent with established models of natural comets. Chemical compositions that suggest the influence of industrial atmospheric manipulation processes. A form that implies an underlying geometric structure concealed beneath a cometary facade. A pervasive silence from official scientific and governmental bodies at every echelon. Independent observations from a multitude of sources corroborating the identical phenomena. Anomalies observed in green comets that, despite their significance, remain unexamined. Solar activity exhibiting a correlation with the passage of these objects that defies statistical probability. Multiple other comets arriving concurrently, each displaying peculiar characteristics. And interwoven with all of this, the revelation of dark celestial bodies powered by unconventional energy sources, the unexpected breakdown of artificial intelligence systems exposing latent complexities, inexplicable quantum occurrences in near-Earth space, and upward-travelling neutrino signals originating from beneath the Earth's surface, which deviate from conventional theoretical frameworks. When all these elements are considered in concert, when one refuses to overlook any individual piece of evidence, and when synthesis takes precedence over compartmentalization, a pattern emerges that becomes exceedingly difficult to dismiss. We're not observing isolated anomalies, we're witnessing a coherent signal. This synthesized perspective reveals occurrences operating across multiple scales. At the cometary level, the appearance of 3 Atlas and its accompanying objects signifies either an unprecedented stroke of luck in the history of our solar system or a deliberate orchestrated event. At the stellar scale, the discovery of dark stars implies that the universe is home to entities possessing concealed propulsion systems and extraordinary durability. At the artificial intelligence scale, the uncovering of hidden failure mechanisms and collapse conditions serves as a potent reminder that complexity inherently harbours unforeseen circumstances. At the satellite scale, quantum anomalies suggest potential interference with our most sensitive observational instruments. At the Earth scale, the Antarctic signal points to a broadcast originating from, or in close proximity to our planet, the nature of which we are only beginning to discern. These are not disconnected events, they are bound by a singular commonality. That commonality is anomaly. That commonality is concealed complexity. That commonality is the universe disclosing that it contains far more than our current models have accounted for. And this unifying thread is leading us toward a specific destination. It points toward conclusions that established scientific paradigms have historically trained us to disregard. This presents a fundamental challenge to our established frameworks. The profound unease underlying this entire examination stems from a single core principle. Conventional scientific methodology adheres to a principle of parsimony. We instinctively favour explanations that necessitate fewer assumptions. We gravitate towards natural processes over artificial ones. We prefer explanations that do not involve the presence of intelligence or deliberate intent. This guiding principle, known as Occam's razor, has served us exceptionally well. It has prevented us from succumbing to unfounded speculation, and has encouraged us to exhaust all naturalistic explanations before considering artificial ones. However, Occam's razor, like any implement, can be misapplied. It can be wielded as a bludgeon to dismiss genuine anomalies, or it can become a convenient pretext for evading difficult questions when faced with data that consistently contradicts our existing models. When it is employed to rationalize the disregard of patterns and anomalies, when it is weaponized to preserve established paradigms rather than explore novel possibilities, then Occam's razor devolves into epistemological authoritarianism. It transforms into a tool for suppressing truth rather than facilitating its discovery. The pattern we have meticulously traced throughout this narrative suggests that an entity approaching our solar system has been the catalyst for multiple anomalies across diverse domains. The most parsimonious explanation, the one requiring the fewest assumptions, might in fact be the presence of something artificial. This is not to assert the certainty of extraterrestrial involvement, but rather because the alternative explanations would necessitate our acceptance that every documented anomaly is a mere coincidence, that every observed pattern is spurious, and that every correlation is purely random. The statistical likelihood of such a scenario is considerably lower than the probability that a real and intentional event is unfolding. This represents a fundamental inversion of conventional reasoning. Typically, the assertion of an artificial origin is considered an extraordinary claim requiring equally extraordinary proof. However, when a naturalistic origin compels us to accept an implausible series of coincidences, when natural explanations demand that we stretch existing models to their breaking point, and when the evidence pointing towards an artificial origin is demonstrably more parsimonious than the evidence supporting a natural origin, then the traditional hierarchy is reversed. The extraordinary claim becomes the naturalistic explanation. The comfortable assumption morphs into the extraordinary hypothesis, requiring rigorous defense. What we should observe in the forthcoming months and years will ultimately determine whether this analysis proves prescient or remains purely speculative. The initial and most crucial indicator is the behavior of 3 Atlas as it approaches its perihelion, its closest point to the Sun. If the object is artificial, and if its companion objects are indeed deliberate, then we should anticipate an intensification of the patterns we have already documented. We should expect the solar flares to become more potent, more frequent, and more precisely synchronized with the object's passages. We should anticipate the chemical and polarization anomalies to become more pronounced as the object is subjected to increased heat and stress from its proximity to the Sun. We should expect the morphology to become clearer if the object's protective outer layer begins to degrade. Conversely, if 3 Atlas behaves precisely like any other comet when exposed to heat, if the solar flares cease or become randomized, and if the anomalies diminish, then we will have gained valuable insight. We will have learned that our anomaly-based reasoning was flawed, and that natural processes were sufficient to explain the observed phenomena. Both potential outcomes hold significance, as both will impart a truthful understanding of the universe. The second indicator pertains to the behavior of scientific data. The James Webb Space Telescope, representing humanity's most powerful observational instrument to date, will have opportunities to examine 3 Atlas in unprecedented detail. The JWST possesses the capability to observe in infrared wavelengths, where morphological features become more distinct, heat signatures are rendered visible, and internal structures can be detected. If JWST data is collected and subsequently withheld from public dissemination, if it is classified or compartmentalized, and if scientists are precluded from publishing detailed analyses, then we can infer that something is being deliberately concealed. Conversely, if JWST data is released promptly and subjected to thorough scrutiny by the broader scientific community, then we can conclude that the institutional mechanisms for suppression are not actively engaged. The distinction between transparency and secrecy, between open scientific inquiry and institutional gatekeeping, will become apparent in the manner in which data is disseminated. This leads directly to the third indicator, the issue of raw data release. Scientists work with FITS files, which are the raw data files containing every photon, every measurement, and every data point acquired by telescopes and satellites. These raw files form the bedrock of all subsequent analysis, but they are not always made immediately accessible to the public. They are often kept within specific research groups, sometimes classified, and occasionally withheld pending the publication of official findings. If the raw FITS files from SOHO observations of 3 Atlas are made available to the general scientific community, granting amateur astronomers and independent researchers access to the same data held by governmental agencies and space programs, then genuine scientific investigation can proceed. However, if these raw files remain restricted, with access limited to vetted researchers operating within established institutional channels, then we can reasonably assume that information is being controlled. The pattern of data dissemination or withholding will offer significant insight into whether authentic investigation is underway or if information management is taking precedence. The fourth indicator involves the possibility of actual intervention. NASA and ESA have been discussing proposals for asteroid intercept missions, which involve dispatching spacecraft to rendezvous with near-Earth objects for the purpose of study and potential deflection if threats are identified. The Juno proposal, in particular, envisions deploying a spacecraft designed to approach an object and collect detailed data in real time, with measurements and observations continuously streamed back to Earth. If such a mission is approved and executed for 3I Atlas, or its companion objects, it would signify that the scientific community has assessed the object as warranting direct and detailed investigation. This would represent a substantial departure from the current stance of institutional silence. It would necessitate budget allocation, the assignment of top priorities, and a willingness to risk a spacecraft on such an encounter. If, however, such a mission is proposed but never funded, indefinitely postponed or rejected despite its technical feasibility, then we can infer that institutional decisions are being guided by factors beyond their scientific merit. The decision to proceed with or forgo an investigation, made at the highest governmental levels, will convey more factual information about the situation than any press release or official statement. The final and most profound indicator concerns public petition and official disclosure. The Freedom of Information Act exists in the United States, and similar mechanisms are in place in other democratic nations to ensure that governmental information is made public, unless compelling national security concerns justify its classification. If citizen groups submit FOIA requests for classified observations and governmental documentation pertaining to 30 Atlas, if courts mandate the release of such information, and if data and analysis conducted by military and intelligence agencies are compelled into the public domain, then truth will have a chance to surface. Conversely, if such requests are denied, if courts uphold classification, and if government agencies successfully maintain secrecy indefinitely, then we can be confident that the system of institutional control remains firmly in place. The resolution of these legal contests, conducted within the normal processes of democratic governance, will determine whether hidden knowledge becomes visible or remains buried beneath layers of classification and compartmentalization. The truly astonishing scenario, the one that occupies the minds of researchers like Lowe and motivates serious investigation despite institutional resistance, is this. What if 3 Atlas is precisely what Tiago initially reported and what subsequent analysis has suggested? What if it is a reconnaissance probe, deliberately entering our solar system, deliberately approaching our star, and deliberately deploying companion objects to trigger solar activity and gauge our reaction? What if these 3 objects are proof-of-concept satellites, demonstrating capability and establishing a presence? What if the entire phenomenon is an act of contact, subtle and cautious, yet unmistakable once one knows how to perceive it? What if everything we have been analysing points towards an intelligence originating from elsewhere in the galaxy, arriving at Earth specifically at this moment, in the year 2025, and we are witnessing the initial phase of humanity's first encounter with non-human intelligence? The implications of such a revelation would be utterly transformative for civilization. Every fundamental assumption about our place in the universe would require re-evaluation. Every religion, every philosophy, every political system would face disruption as the undeniable reality of other minds, other civilizations, and other possibilities became manifest. No government desires such disruption. No institution seeks such a radical transformation. This is precisely why silence is maintained, why data is compartmentalized, and why anomalies are explained away. The alternative, the acknowledgement of such a presence, is simply too destabilizing to embrace willingly. Yet, or perhaps precisely because of this immense pressure, the question urgently demands to be posed. Are we witnessing the inaugural act of a cosmic contact event, humanity's inaugural genuine encounter with intelligence from beyond our world? Or are we being systematically deceived by artifacts and biases, by pattern recognition running rampant, by confirmation bias that finds significance in noise and perceives intention where only randomness exists? The answer to this question is profoundly important. It will dictate how we understand ourselves and our position within the cosmos. It will determine the trajectory of humanity's future. And at this present moment, the answer remains genuinely uncertain. The evidence strongly suggests one particular direction. The persistent institutional silence only reinforces this suspicion, yet absolute certainty remains elusive. This is the point at which you, the viewer, must assume the role of an investigator yourself. This is where skepticism must transmute into curiosity. This is where a comfortable embrace of uncertainty must become your foundational principle. Because the truth, whatever its nature, will ultimately emerge not from pronouncements of judgment by authorities, but from information becoming publicly accessible, from data being subjected to open examination, and from individuals who refuse to accept official silence as a sufficient substitute for genuine inquiry. The pattern is undeniably present. The anomalies are thoroughly documented. The crucial questions have been posed. What transpires next hinges on whether a sufficient number of people care deeply enough to demand answers. The data exists. The observations have been meticulously made. The evidence has been systematically gathered. What remains is for those of us who perceive the pattern to articulate it, to disseminate it, and to resolutely prevent it from being buried beneath institutional inertia and comforting assumptions. 3 Atlas continues its trajectory towards perihelion. The companion objects maintain their relative positions. Solar activity is escalating, and somewhere within classified files and compartmentalized data, governments and space agencies possess knowledge that they are not divulging. Whether they will ever voluntarily disclose what they know remains uncertain. Whether the public will ultimately compel such disclosure through legal avenues and political pressure remains to be determined. However, one fact is irrefutable. Something is occurring. Something tangible. Something empirically documented. Something that fundamentally challenges our comfortable perceptions of the universe and our place within it. And the only appropriate response for a species capable of critical thought is to confront that something directly, to examine it without flinching, to demand clear answers, and to steadfastly refuse to be silenced by institutions that benefit from our lack of knowledge. The truth is indeed out there, and contrary to the assertion of a popular television program, it is not concealed in the shadows. It is plainly visible within our data. It is meticulously documented in our observations. It is waiting for us to possess the courage to truly see it.